Alright, so our order of operations goes grouping symbols, exponents, multiply and divide, and then add and subtract. So an absolute value symbol is a grouping symbol. So we're going to first evaluate what's inside of there. Negative 3 plus 9 is 6. So it's the absolute value of 6 minus 10. The absolute value of 6 is 6. And 6 minus 10 is negative 4. Again, first thing on our list, grouping symbols. 4 minus 15 is negative 11. So I'm going to bring down the absolute value of negative 11 and bring everything else down as well. Now the absolute value of negative 11 is 11. Bring down everything else. Now from left to right, we're going to add and subtract. So 7 plus 11 is 18. And 18 minus 2 is 16. Alright, so try these two on your own, pause the video, and then play it after you're done. Alright, if you're not done yet, pause the video. If you are done, then listen up. 7 minus 10 inside of our absolute value is negative 3. The absolute value of negative 3 is 3. And 3 plus 14 is 17. Negative 15 plus 6 is negative 9. Bring down our absolute value symbol and everything else. The absolute value of negative 9 is 9. Bring down everything else. Multiplying comes before subtraction, so 3 times 9 is 27. Bring down everything else. And then 27 minus 2 is 25. Alright, try these two out on your own and pause the video. Alright, if you're already done, then listen up. Inside of our grouping symbols, which are absolute value, I see two operations, addition and subtraction. I'm going to go from left to right. So first I have negative 14 plus 6 is negative 8. Bring down everything else. Now negative 8 minus 12 is negative 20. Bring down everything else. The absolute value of negative 20 is 20. So our answer is C. Alright, over here again, inside of the absolute value, which is our grouping symbol, I see two operations. I see square root and multiply by 2. So first we're going to do the square root. The square root of 9 is 3. Bring down everything else. 2 times 3 is 6. Bring down everything else. The square root of 6 is 6. Bring down everything else. And negative 6 plus 2 is negative 4. Now one thing to look at on this one is it's weird that the 6 came out negative. It's because the negative was outside of the absolute value. So first we have the absolute value of positive 6 is positive 6, and then this negative sign that's out in front of it. Alright, so now we're going to use what we know about absolute values to solve some equations. This first one's very simple. It's just the absolute value of x is equal to 4. So because this is inside of an absolute value, we're trying to figure out what value x could have that the absolute value of x would be 4. So first of all, x could be 4 because the absolute value of 4 is 4. But there's also another option. X could equal negative 4. Now here's why. The absolute value of negative 4 is also 4. So whenever we're solving an equation with absolute values, we're always going to end up with two different solutions. X could equal 4, or negative 4. Now, we're going to use what we know from that to solve this more complicated equation. Now, if I think about my operations that are happening to x, first it's being multiplied by 2, then subtracted by 8, then absolute valued, and then added by 5. So doing those in reverse order, the first thing I'm going to do is, just like normal, subtract 5 from both sides of the equation. So I get the absolute value of 2x minus 8 equals 10. Now that this whole left side is inside the absolute value, just like before, this problem is going to split into two parts. 2x minus 8 could equal 10, or 2x minus 8 could equal negative 10. And we need to solve both of these. So in both cases, we're going to add 8 to both sides, and then divide by 2 on both sides. So our first solution is x equals 9. And our second solution is x equals negative 1. So just like before, since we have an absolute value and the x is inside of the absolute value, there's two possible solutions. The reason for this is because absolute value means the distance away from 0. If we plug back these values in there, we can see that they both work. 2 times 9 is 18, minus 8 is 10. The absolute value of 10 is 10, plus 5 is 15. If x is negative 1, 2 times negative 1 is negative 2. Negative 2 minus 8 is negative 10. The absolute value of negative 10 is 10, and 10 plus 5 is 15 again. So because of this absolute value, either negative 1 or 9 will make this equation true. Try out these two on your own. Pause the video. Alright, so because we have our absolute value, we know that we need to split this into two different equations. 3x could equal 12, or 3x could equal negative 12. In both cases, we're going to divide by 3, get x equals 4, or x could equal negative 4. 3 times 4 is 12, the absolute value of 12 is 12. 3 times negative 4 is negative 12, the absolute value of negative 12 is 12 also. Alright, this one, because we don't have the whole thing inside of the absolute value, we're first going to add 7 to both sides. And then we get the absolute value of x minus 4 is equal to 12. So x minus 4 could equal 12, or x minus 4 could equal negative 12. If we add 4 to both sides, we get x equals 16, or x equals negative 8. One last way that we can use these absolute values is with inequalities. And this is just like it was with equations, but with one little wrinkle added in. So just like before, because of these absolute value symbols, we can split it up into two inequalities. 2x minus 8 could be less than 12, or negative 12. Here's the thing though. Remember from before when we were solving inequalities that when we multiplied or divided or changed the sign in any way, the direction of the inequality needs to change. So just like this, when we change sign from positive 12 to negative 12, this sign needs to change to a greater than sign. Now it's just like normal. We can solve both. So x is less than 10, or x is greater than negative 2. So on a number line, we have negative 2 and 10. X could be less than 10 or greater than -2, so it's right there in the middle. Try out these two on your own. Pause the video. Alright, so we're going to split this into two inequalities again. We have 4x minus 8 is greater than 16, and we can solve that one. X is greater than 24. Divide by 4, and we get x is greater than 6. We can also, the negative version, 4x minus 8, could be less than negative 16. Add 8 to both sides. Divide by 4. So x could be less than -2 also. On the graph, that would look like less than -2 or greater than 6. So these ones go outward. Alright, now let's take a look at this other one. There's not enough space here to really do this one, but the answer is D, so check yours there.